Let's just do it. Okay, tomorrow, if you look at the board, tomorrow is the 20-point quiz on the derivatives.
What?
Oh gosh.
What?
Is it just derivatives?
And integrals.
Oh, is that from the sheet?
Yes. So let me give you a sample.
Oh,
You're
sound.
gonna have 10 derivatives and 10. This is where you're gonna boost your average.
Is
right
this
here.
speed? Is
You
this
need
speed?
a cushion.
Is this
I'm
speed?
telling you right now, because don't accidentally bump that now.
Oh yeah.
Zach.
Because just believe me. Because once we start doing the daily quizzes, like I told you,
Why, you're gonna fail every day?
some of you might.
Mr. Parker, I need to do good this quarter.
Yeah. Okay, so let's get 20 out of 20. Come on. So the first 10 on the left hand is going to be all derivatives. It's going
Oh,
to
so
look
you're gonna-
like
Wait,
this.
so we don't need to do any homework if we can do that on Friday.
Oh, no. Like this. Equals,
Oh, that's
and then
all?
you just fill in the blank right there. So what's the derivative of sine box? Is it just cosine box?
Times the
No.
box.
Times, not the box, the derivative of box.
Box.
And you don't have to bother simplifying your answers, because I just want to see if you can do it.
Oh,
You
so
know
if
what
it's
I'm talking
super
about?
like huge.
Like here, what is the derivative of e to the, oh, I don't know, here, let's go with e to that. What's the derivative of e to the box? Is it just e to the box?
No.
No, then you gotta
Derivative
times
of
it by
box.
the derivative of box, which is negative cosecant x cotangent x.
Holy.
That's it, and you just put it.
So that's the whole left-hand column of derivatives. The right-hand column could be integral. So the right-hand column, like what's the integral of cosine 5x dx? Is it just sine 5x?
No.
No.
1/5.
You have to put a 1/5 to adjust for the derivative of box. And don't forget to put plus c, otherwise you're going to get minus 10 right there. I will remind you before the quiz.
Yes.
But come on, anytime you do an antiderivative, there has to be a plus c there. So all you gotta do is your list of derivatives and integrals. That's like your multiplication table for the AP exam. All right. Now, do we need to go through all of the limits? What the heck, let's just do it, right? Okay, what is the limit as x approaches 2 of x cubed minus 8 all over x squared minus 4? How many people factored and canceled? How many people use L'Hopital's rule? Oh, and you guys are the ones grumbling. How come we gotta learn L'Hopital's rule? And now you want to use it. We should get a backhand. Anyway, whatever. So what, L'Hopital's rule? Okay, so take the derivative of the top, take the derivative of the bottom, and then did you cancel right now? This x cancels into one of those x's. Now plug in 2 and you get 3. Finished. Isn't that so easy, L'Hopital's rule? Okay, B. And then I gave you all the answers now, right?
Yeah.
I gave you all the answers. There should be no excuse. Limit x approaches 0. Sine squared x over 1 minus cosine x. So I'm assuming everybody's using L'Hopital's rule now. Just make sure it's 0 over 0 or infinity over infinity now. So if you take, it is 0 over 0, take the derivative of the top. Now remember, when you have a trig function raised to a power, rewrite it like that. So you have box squared. So 2 box to the first times the derivative of box. And then what's the derivative of the bottom?
Fine.
Sine x. The signs cancel out. Plug in 0 now. 2. L'Hopital's rule is so easy. Now, limit as x approaches infinity of sine inverse x plus 3 over 2x plus 5. As x approaches infinity, what does this go to? Yeah, if the degree at the top and the bottom are the same, we look at the coefficient. So this goes to 1/2. And what is sine inverse 1/2? Pi over 6. D. What is the limit as x approaches infinity of x squared over 2 to the x? Well, this would be an infinity over infinity case, so you could use L'Hopital's rule. But I would hope that you would just go, apple. This is polynomial. This is exponential. Which one grows faster to infinity? Exponential. So if the bottom is growing much faster than the top, the limit must be 0. Okay, E. Now the next three are just all derivatives. This is the definition of the derivative. We went through this yesterday. So this is the derivative of what function? Right there. And what's the derivative of 5 to the x? 5 to the x times ln 5. Not divided by, times. Because we're taking a derivative, not an antiderivative. Okay, F. Limit h approaches 0, natural log of 2 plus h minus natural log 2 all over h. This is the definition of the derivative. And again, like I told you yesterday, think of that as x. What function are you taking the derivative of? Natural log x. And what is the derivative of natural log x? 1 over x. But there's a 2 there. That means we're evaluating the derivative at x equal 2. So just plug in the 2 there, and the answer is 1/2. See how easy this is? And then g. Okay, I'm not going to, I'll just write it out. Limit x approaches pi over 6, f of x minus f of pi over 6, all over x minus pi over 6, if f of x is equal to cotangent x. This is the definition of the derivative. What is this equal to, by the way? F prime of pi over 6. So that means you're just computing the slope when x is pi over 6. But what function do I take the derivative of? Well, I told you what it is. Right there. So if f of x is cotangent x, what's the derivative? Negative. Don't worry, I'll know tomorrow, Mr. Park. And then you need to plug in pi over 6 into that. So what is negative cosecant squared pi over 6? Negative, what is cosecant of pi over 6? 2 squared, 4, so negative 4. So are we recognizing the derivatives? 2. Looks like we're just doing them all anyway. F of x is equal to the e to the x minus 1 over e to the x plus 1. It says compute f prime of natural log 3. That means take the derivative and then plug in natural log 3. You know, a lot of these problems I just got off the multiple choice section of the test. So how do I take the derivative of something over something? Should I make up my own rule or use the quotient rule? Quotient. Yeah, I think you should use the quotient rule. So low d high minus high d low all over denominator squared we go. And then when you plug in natural log 3, what is e to the natural log 3? 3. Yeah. So e to the natural log 3 is just 3, so you get 3 plus 1, oh, it's ugly, times e to the natural log 3, which is 3, minus 3 minus 1 times 3, all over 3 plus 1 squared, and I think you guys can compute that. Yeah? You guys can take it up. Yes, and tomorrow there will be product rule and quotient rule on the quiz too, so make sure you can do that. Okay, number 3. How come that's not up there? That's like probably one of the toughest problems. You guys are strange. Cosine 2x plus 2 sine x. For what values of x between 0 and 2 pi is the derivative equal to 0? So first step, make sure you take the derivative correctly. Okay, what's the derivative? Paulo?
What? Oh, negative 2 sine 2x plus 2 cosine.
Okay, and we want to know when is this equal to 0? So we need to use identities. What identity am I going to use for sine 2x? I'm telling you right now, you gotta know double angle identity. Well, you pretty much gotta know all your identities except the half angle on the AP exam. So this is what we got. Negative 4 sine x cosine x plus 2 cosine x. When is that equal to 0? Factor. What can I factor out? Should I factor out the negative? I would. And then a 2 cosine x. What's going to be left?
2 sine x
2 sine x minus 1. So if something times something equals 0, that means either this is 0 or this is 0. And then of course you guys should know your trig values here, right? Cosine of what angle is 0? Pi over 2, 3 pi over 2. Sine of what angle is a half? Pi over 6, 5 pi over 6. They're not going to try and trick you on the AP exam. They just want to see if you know calculus. Okay, number 4. I guess we're just doing them all. Okay, we need room here. Okay, number 4. F of x is equal to 2x plus 1 all over absolute value of x plus 1. Okay, now what do you do? Now this is pretty much the difference between a 4 and a 5 on the AP exam. You gotta know how to handle absolute value. What do you do when you see absolute value? Skip to the next problem? No, you make a piecewise function. Okay, remember, if the inside is positive, you leave it alone, so you just get x. But if the inside is negative, then you negate it, right? Remember? The absolute value of gorilla is either gorilla or negative gorilla, depending on whether the inside is positive or negative. So if x is greater than or equal to 0, that means the inside is positive, so it's just going to equal to x, and you're going to get this. But if x is less than 0, then this is equal to negative x, and you get this. You need to make a piecewise function. Guarantee it's going to come up on one of the problems on the free response every year. Okay, now we got to compute some limits. Now, there's two things you can do. You can draw the graph, or we can just use the techniques we learned to compute the limits. Yes?
How do you do the x is greater than or equal to 0? Like
Yeah,
if you
whatever
have like
make-
a minus 3 or something, x minus 3 inside, would it be...
Yeah, so if you had absolute value of x minus 3, then you would have x is greater than or equal to 3, or x is less than 3.
And then how do you know if you include the...
You can put it on either.
Oh,
Normally, we could just put it on the greater than one, but you can put it on either.
Okay.
Okay, so what do you guys want to do? Draw the graph or just try to compute the limits? Okay, let's compute the limits. Let's see if we remember how. A, what is the limit as x approaches infinity of this function? First of all, which piece do I look at? X approaching infinity. You look at this piece because x is greater than 0, right? So what's the limit as x approaches infinity of this? If the degree of the top and the bottom are the same, you look at the coefficients too. B, what is the limit as x approaches negative infinity of f of x? Well, as x approaches negative infinity, that's when x is less than 0, so you look at this piece.
Negative.
So it'd be negative 2. See, the key is you gotta write that piecewise function there. What is the limit? No, we're not even finding that. What is f prime of x equal to? Well, if your original function is in pieces, then your derivative is going to be in pieces. So since this is a quotient, you got to use the quotient rule. So low d high minus high d low all over denominator squared we go. And I'll leave the simplifying to you so we can save time. And then this one. Low d high minus high d low all over denominator squared we go. I'll leave the simplifying to you. And then part D. What is f prime of 0? That means what is the slope when x is 0? So how do you think I'm going to find it?
Plug it in.
Yeah, plug it into which one though?
Top.
Yeah, you have to plug it into both because the derivative tells you the slope. And again, remember, if the graph comes to a sharp point, then the derivative doesn't exist. So what happens when you plug in 0 into this? You might want to look at the simplified one that's the answer. Or how, just do it in your head. Plug in 0 for x here. What do you get? Did anybody do it? Just tell me what you got. Okay, so if you plug in 0 into this, you're telling me you get 1. What happens if you plug in 0 into this? You sure? Okay, I'm trusting you. Now, is that the same number? See, that means the left-hand slope and the right-hand slope are not the same. That means coming from the left, when x is less than 0, the slope is 3, so it's like steep like that. And then when x is greater than or equal to 0, the slope is 1, so it's going to look like that. The graph comes to a sharp point right there, which means this does not exist. Because in order for the derivative to exist, the left-hand slope and the right-hand slope got to be the same so that the graph will be smooth. If the left-hand slope and the right-hand slope are different, then it's not going to be smooth. Therefore, the derivative does not exist. Yes?
How come on the answer key it doesn't include the equal sign?
Okay, very good. How come it doesn't include this? That's because at 0, the derivative doesn't exist. And so that's why you can't include it, because it doesn't exist.
You're not gonna
But in
care.
the,
Put it on the x.
I don't think they will take off a point for that. See, that's why these problems, I wrote these problems so that you can learn everything you do. This is not busy work here. You're going to learn something from it. Okay, number 5, 6, 7, did basically everything. Okay, 5. F of x is equal to 4x plus 1 to the 3/2 power. Write the linearization of f when x equals 2. Now this is guaranteed. This is guaranteed on the free response right here. What the heck does linearization mean? The equation of the tangent line. Write the equation of the tangent line. Now, what do you need to write an equation about tangent line? You need a point, and you need the slope. Now, how the heck do I figure out the point? Well, it says when x is 2, if x is 2, how do I figure out the y coordinate? You plug it in. So if you plug in 2 there, what do you get? 8 plus 1 is 9. What is 9 to the 3/2 power? And again, 9 to the 3/2 power, square root it first, and then cube it. Huh? Okay, 27. Now, how do you find the slope of the tangent line? You got to take the derivative. Okay, what's the derivative of box to the 3/2? Is it just 3/2 box to the half times the
4.
derivative of box, which is 4? And you want to simplify it? 2 goes into 4 2 times? I think we should. And please don't forget the 1/2 power, because a lot of people put the power in the front, but then they forget to reduce the power by 1. That's a common mistake. So if I plug in 2 into here, that will tell you the slope. So plug in 2 there. 8 plus 1 is 9. 9 to the 1/2 power. 18. That is 3 times 6, 18. So what's the equation of the tangent line? Y minus 27 equal 18 times x minus 2. Well, what do we do when we do linearization? We solve for y like this. Don't distribute the 18. Just leave it like this. Just add the... Now, if you look at the book in my notes, there's a formula for linearization. Did anybody look at it? Okay, did you use it? Okay, you can, but all it is just what I did here. So I would suggest you don't memorize the formula for linearization. Just write the equation of the tangent line and solve for y. Okay, now, use your result to estimate f of 2.1. Well, instead of plugging in 2.1 into this ugly function here, you plug in 2.1 into the equation of the line, like this. Because look how easy this is. 18 times, what's 2.1 minus 2? 0.1. That's why you leave it in that form. Plus 27. What is 18 times 0.1? 1.8 plus 27. Now, of course, on the AP exam, you could just leave your answer like this, but come on, you're allowed it. So 28.8. So that would be a pretty good estimate of what if I plugged in 2.1 into this. And again, what's the concept of this? You have a graph that looks like this. Now, I'm not sure what it looks like. Right here, when x is 2, we wrote the equation of the tangent line. Like that. When x is 2.1, can you see that the y-coordinate on the line is very close to the y-coordinate on the actual curve? Yeah, it's very close. That's the concept of linearization. So we figured out the y-coordinate on the line here. That's 28.8. So the one on the actual curve should be pretty darn close to 28.8. Now, is this an over or an underestimate? They always ask you this. How do you determine that? You have to look at the concavity of the graph. Because look, if the graph is concave down, then isn't the point on the line above that, so it's going to be an overestimate. But if the graph is concave up, then see, when you draw the tangent line, the point on the line is going to be below the actual curve, then that's an underestimate. So we need to compute the concavity of the graph when x is 2. And how do we do that? What tells you the concavity of the graph? The second derivative. Okay, here's the first derivative right here. Throw the 6 on the side like an unwanted pet. What's the derivative of box to the half? 1/2 box to the negative half times the derivative of box. Now, I plug in 2, and what do you get? 6 times a half times 9 to the negative half power times 4. What does that come out to? 3 times 1/3 times 4. That comes out to 4. Is that a positive or a negative number? No, it's a positive number. So does that mean the graph is concave up or concave down? Yeah, if the second derivative is positive, that means the graph is concave up, which means that the tangent line is actually below the curve, which means we have an underestimate. That's how you determine it. That's guaranteed going to be on the free response. There are certain concepts that they have to test you on, and that's one of them right there. Do we understand that?
Wait, it's...
I think I put the explanation in the answers, didn't I? Louis is looking at it now. Okay, there it is.
Wait, why is it an underestimate again? Because of that?
No, it's an underestimate. Because the second derivative is positive, which means the function is concave up, right? And if the function is concave up, then look, when you draw in the tangent line, the point on the line is below the actual point on the curve. So because this is the y-coordinate of the point on the line, isn't it less than the actual y-coordinate on the curve?
Just because it's positive.
Yeah, because remember, how do you determine if a graph is concave up or concave down? The second derivative. If the second derivative is positive, it's concave up. If the second derivative is negative, then the graph is concave down.
Oh.
Okay, number 6. Okay, this problem is always on the test. Sometimes it's on the free response, sometimes it's multiple choice. Now, if it's multiple choice, then you don't have to like justify any answers. But if it's on the free response, then you gotta justify. Is this function continuous at x = 4? In other words, does it like meet? How can you tell? That's when you have a piecewise function. Well, if I plug in 4 here and I plug in 4 there, do you get the same number? Yeah, square root of 4 is 2, 8 over 4 is 2, yeah. So it's continuous, but now the second question, is it differentiable? So we know that the graphs meet, but then is it smooth? So here, let me show you what's going on. Here's when x is 4. Now if you graph this, it kind of looks like this. And then if you graph this, I'm not sure what it looks like. It looks something like that. Now, if you just sketch the graph, you can kind of see that that's a sharp point. So it is not differentiable. However, they're going to want you to justify your answer. Just drawing a graph is not good enough. So how do you determine if the left-hand slope is the same as the right-hand slope? You look at the derivative. Remember, this is a calculus test. Probably you're going to take either derivatives or integrals when you do this test. So, what's the derivative of radical x? Hopefully we remember I told you guys to memorize that. 1 over 2 root x. And then what's the derivative of 8 over x? I told you to memorize that one too. Negative. That's like 8, okay, if you have to, that's like 8x to the negative 1.
X
Negative 8x to the negative 2. Which is that. Remember I told you the derivative of 1 over x is negative 1 over x squared? It comes up so often. Well, whatever, you don't have to. Just take the derivative correctly. So if I plug in 4 here and 4 there, do you get the same number? Plug in 4 here, what do you get? 1, 4. Plug in 4 there. Negative 1/2. See, this is the left-hand slope. See how the left-hand slope is kind of like that? 1, 4. This is the right-hand slope, negative half. The left-hand slope and the right-hand slope are not the same. Therefore, it is not differentiable there. It's not smooth. It comes to a sharp point. Oh my goodness. Okay, number 7. Oh, by the way, are you guys looking at your notes as you go through these problems? Now, what if, oh, they didn't even ask for an explanation. Okay, but on a free response, you're going to have this problem. They're going to ask you, is this function continuous at x equal to 4? Yes or no?
Yes.
Yes, okay, you get 1 point. You want the second point, they're going to ask you why. Explain. Now, if you look at your notes, it tells you the definition of a function being continuous. And I asked you on the test,
Oh,
I'm sure you forgot.
F of A.
Because the limit
Oh, limit of
of this function, that's an ugly L. The limit of this function as x approaches 2 or 4 is equal to
F of x.
f of 4.
What the?
Oh, that's
all
all
you
It's
you
on the notes!
That's all you put, yeah.
Huh?
That's all you put, yeah.
If you want to expound a little more, then you can say they're both equal to 2. Right? Because if you plug in 4 here, you get 2.
Yeah, but they'll take that. They just take that.
I think they will take that.
I mean,
They want you to refer to the definition, that's why.
well, that's it.
Yeah.
So if you like calculated both and it showed that they're both equal to 2,
Because-
does that count?
Say that again.
So like if you plugged in 4 for both of them and then you said that they're
Well, that will just tell you if it's continuous or not, but then you gotta say why.
Oh, so
This is
that
why.
doesn't count as an explanation.
No.
Oh,
You cannot like write in words. Do not write, oh, because if you plug in 4 here and plug in 4 there, you get the same number.
Because it's smooth.
Because that does not refer to the definition. Just believe me, I've been grading AP exams for a long time. Okay, number 7. Okay, you guys are supposed to do up to 7. So here's the last one. Now, how much, oh my goodness. Okay, at what values of x does f have a maximum or a minimum, and explain your answer. Okay, now pay attention now. How do you determine whether you have maxes or mins for a function?
Number 9.
You take the derivative first, which I gave you, and then you make a number line. And like I was telling you yesterday, whenever you make a number line, you must label it. You have to, and you have to label it correctly. What goes on the number line? Negative half and 2. And how do I know it's going to be plus, plus, minus? How come it stays the same sign here? You got even power. And if you cannot remember anything about the patterns that we learned, just plug in a number here, plug in a number there, plug in a number there. And then now, what do I need to write underneath it to get the credit? Remember what I told you? If the first derivative is negative, what does that mean? The function is decreasing. Remember that? If the derivative is positive, that means f is increasing. Positive, f is increasing. Mr. Park, can I just make one f increasing going all the way across like that? Yeah, you can, but you're going to lose a point. You know why? Because at x equal 2, it is not increasing. Because when you plug in 2, the derivative comes out 0. It's only increasing if the derivative is positive. I'm telling you what to do.
Unless you make a table.
There's no
If
table.
you make a key, then it
A
makes
key,
the
key.
line.
Oh yeah, you can make a key.
Make key, make.
No, but you can't just go all the way across. You gotta make one here and then another one
Yeah, but
there.
that's easier.
You cannot just make one going all the way across.
Or you can just write like super small so it looks like a line.
Okay, you're probably only gonna do this once on the free response. Why can't you just write it out?
That's
Alright.
boring. That's what I mean.
Oh, can't you be bored just for this one day?
Maybe.
Okay, so looking at this thing, is there a relative maximum?
Huh?
Is there a relative maximum?
No, there's
No.
a minimum.
No.
There's a minimum though.
Okay, there's a minimum here. Okay, so there is a minimum at x equal negative half because now I didn't tell you this when we first learned it because I didn't want to overload you, but now I have to teach it to you because before, up until about 3 years ago, that's all you needed was that. But now they sent an email to all the calculus teachers in the nation and they said that's not enough anymore. So anytime you have to justify a maximum or a minimum point, you have to include this next sentence I'm going to tell you. There is a minimum at x equal negative half because f prime changes from negative to positive. That has to accompany the number line now.
What?
Look, I'm just telling you what they want. This is what they want. You guys get that?
Yes.
So how would you justify a maximum point then? Like here, what if you made a number line for the derivative?
Plus
Let's say
5.
this is 2 and 5. And then you get plus minus plus, f is increasing, f is decreasing, f is increasing. There is a maximum at x equal 2 because
Positive.
f prime changes from plus to minus. There is a minimum at x equal 5 because f prime changes from minus to plus. You have to put that sentence in.
Oh, so how does it change with concavity?
Okay, so that's the next thing. Okay, how do you find points of inflection? You gotta make a number line for the second derivative. Now here's the first derivative. How do you find the second derivative? What do I want to multiply it all out and then take the derivative, or should I use the product rule? Yeah, I think you should use the product rule. So derivative of the first, leave the second one alone, plus leave the first one alone. What's the derivative of the second one? 2 box to the first times the derivative of box, which is 1. What can be factored out? I can factor out a 2. I can factor out a x minus 2. What's left? You need it in factored form, people. X minus 2 plus 2x plus 1. And so, simplifying everything, we get 3x minus 1. That might be the hardest part for you guys right there, so simplify. So, when I make my number line for the second derivative, look. What goes on the number line? 1/3 and 2. How do I know it's plus minus plus? Okay, now what do I need to write underneath it to get full credit? If the second derivative is positive, that means f is concave up. See? Remember doing this? If the second derivative is negative, that means f is concave down. Now, you don't need to write it like that, but remember I told you we're Iolani, right? Anyway, whenever the graders, they look at this thing. They must be from Iolani. F is concave. I'm telling you. Look, that's a visual thing. Okay, so what are we trying to find? Point of inflection. Now, what the heck is a point of inflection again? When it changes concavity. So we have points of inflection at x equal 1/3 and x equal 2. And again, you have to include the sentence because I think you can figure it out. Because what? Why is there a point of inflection here?
Because f double prime changes from positive to negative.
And then what about there?
Negative, positive.
Yeah, so can't you just say because f double prime changes sign?
No!
Yeah.
Oh, okay.
Now, do you see the difference? When you do maximums and minimums, like if it's a minimum, you have to say it changes from negative to positive. And for a maximum, you gotta say it changes from positive to negative. But for points of inflection, you just need a change in sign. It doesn't matter if it's plus to minus or minus to plus, right? It just has to change concavity. You guys see the difference between the two? Okay. Well, that took almost the whole time. Shall I get you started on number 8?
Yes.
Yes. Anyway, you guys need to look at your notes. No, never mind. You can do it all for us anyway.
Hey, don't you need to put, you know, on all those F's,
Yeah.
are you sure it's just F or does that have to be?
Wait, let me look. Yeah.
Oh. Like,
Now, of
F
course, if they
prime
told you, if they
decreases.
said y prime here, if they said y prime, then you gotta say y is decreasing. Y
But
is
not
increasing.
F prime.
No. See, you have to show them that you know the relationship between a function and its derivative. If the derivative is negative, that means the original function is decreasing. You have to. Okay, Now, what happens when you have, like, normally when we have functions, we're given it as like y equals, right? But what happens when it's difficult or impossible to solve for y?
Implicit.
We do implicit differentiation. Does that sound familiar? Okay, how do you do implicit differentiation?
Separate.
Derive.
No, this is not separated variables.
Oh,
Okay, just remember, okay, the derivative of, we're taking the derivative with respect to x. So
Wait,
when
what
you
are we
take the
doing?
derivative of x, you get 1.
what does it ask you to do again?
We're trying to find the derivative, dy dx. But when you take the derivative of y, you get dy dx. Or you can put y prime if you want.
Oh yeah.
Okay, so here we go. When you do implicit differentiation, you just take the derivative of each term, term by term, left and right side of the equation. So, think of this as 3 box squared. What's the derivative of 3 box squared?
3,
6 box times the derivative of box, which is 1. The
One.
derivative of x is 1, because we're taking the derivative with respect to x. Now over here, this 2 can be thrown on the side. How do I take the derivative of x times y?
Product.
You gotta use the product rule. So derivative of the first, 1, leave the second one alone. Then you leave the first one alone, and what's the derivative of y?
Why not?
dy dx. Or you can put y prime if you want, because they mean exactly the same thing. Plus, I got box squared. How do I take the derivative of box squared? 2 box to the first times the derivative of box, which is dy dx. Equals, and the derivative, of course, of 24 is 0. Now, how the heck do you compute dy dx? You gotta solve for dy dx. So here, multiply out everything. 2y plus 2x dy dx is equal to 2y, plus dy dx equals 0.
Oh.
Put all the dy dx's on one side. Now that's why it might be better to write y prime. So put everything else on the other side. Factor out the dy dx. 2x plus 2y equal negative. What is that sum? So dy
That's
dx
a camera.
is equal to negative 6x minus 2y all over 2x plus 2y. And shall we simplify that?
No.
Divide top and bottom by 2 and you get? Negative 3x minus y over x plus y. There's your derivative.
Oh, that's the answer?
No, well, yeah, for dy dx, but then now you gotta answer questions about it.
Picture.
Yeah.
For B, you make,
With numerator 0. Okay, so just try, okay, this is what you gotta do.
Oh.
I think you guys should try to do up to number 13.
What?
That's crazy
okay, why do you make the numerator?
Because it says horizontal tangent. What's the slope of a horizontal line? Yeah, so you want the slope equal to 0. Yeah, so you make the top 0, and then you plug it back into the original.
Wait.
Make the denominator 0, because the slope of a vertical line is on the
Okay.
line. Okay, we'll finish up.
Wait, and what do you plug? Do you plug
For part B,
Yeah.
so horizontal tangent,
Right, so you
set the
make it
numerator
zero,
equal to 0, solve for one of the letters, probably y, and then plug it back into the original.
Okay.
We'll do it all tomorrow again.
Is it hard?
You know what?
Oh,
Yeah. Yes?
is it derivatives added?